Hi, thanks for joining today. I'm Anirban Sengupta. I'm Senior Director of Engineering for Google Kubernetes Engine. And with me is Eduardo, right? He is from one of our customers. Can you guys? Okay, I'll wait for a couple of minutes, maybe. Works? Works? Okay, cool. Let's start again. So I'm Anirban Sengupta. I am Senior Director in Google. I manage the engineering team for Google Kubernetes Engine. And with me is Eduardo from Near Protocols. Right, he's one of the great customers of Databricks and running on Google Cloud. And so this is two of us, and today we also thought that we'll be tuning. So once he comes up, you'll see that we are the only two people who are wearing a white jacket in the whole conference. So let's talk about Databricks running on GCP. So there are very key things which we want to talk about when Databricks is running on GCP. So the first thing which we talk about is about differentiated services, right? So GCP is the only place as of now, right, where Kubernetes runs, where Databricks runs on Kubernetes, right? And what we are seeing is that, Eduardo is going to come up and talk about the scalability and the experience which he is getting as a customer, right? But we see really great differentiation, right, when we run it on containers versus we run it on VMs, right? And that gives a much better scalability and TCO, right? And the second piece, is that it's well integrated with the data services that GCP provides. So it's including BigQuery, PubSub, it's fully integrated with it, right? And also, Google provides one of the best AI ML platforms. So it is also included and connected to Looker for analytics. It's connected to Vertex AI for the whole stack. So for customers who are looking at full data services, including analytics with Databricks and LLMs, right, this is like a really differentiated platform from end to end. On the performance and scalability side, right, so we are seeing a much better TCO, and a lot of our customers are looking at it. When we run it on Kubernetes, right, then we see like at least a 20% better cost savings, right? And for certain applications, we even see 5x plus, right? With large clusters and large number of services, we see really, really great performance on that. The second part is scalability. So Google Kubernetes Engine provides like the best scalable from node perspective. We support up to 15,000 nodes, right? And that creates a very easily scaling of nodes. And the part which is very interesting also is that we do auto scaling and right sizing. So what happens is that when the data load goes down, right, it would size it down, which really helps in cost savings for the customers. And last but not the least, we have one of the best security out-of-box experience, right, on GCP. So it's secured systems, data, and resources. And also the other part is that our customers use the integrated IAM identity, and also they use the integrated security services, right, and the secret services. Last but not the least, we out of the box, which provide policies, compliance, right, whether it is FedRAMP, IL4, right, or even the higher level services, right, and compliance. So that really helps our customers to deploy with governance and compliance. So before I hand it over to Eduardo, I just want to go and provide a high level architecture, but I call it marketecture, right, for Databricks, how it runs. So below that, we have all the GCP services, starting from identity services, the Kubernetes engine, and all the other GCP interfaces and marketplace. On top of that, right, we run the whole Databricks stack, right, starting from the Lakehouse platform, all the IQ, Unity, all the services. But the great thing is that it's completely integrated with all the analytics and AI/ML services that GCP provides, right? So we have integration with PubSub, we have integration with BigQuery, Looker for analysis, and also Vertex AI for the whole LLM stack, right? And it's also really great when we look at how developers are using the whole stack, right? All the way from data lake to AI/ML and LLM-based modeling. With that, I'll hand it over to Eduardo.
Thank you very much, Anirban. Can everyone hear me? Excellent, thank you. All right, so to present NEAR, I will show a few metrics. So in simple words, NEAR is blockchains abstracted. Our goal is to make it easier for Web3 developers to build their applications or their decentralized applications easier and across all the blockchains. So a few numbers. Data is as early of June 2024, and our market cap is around 7.8 billion. We are the number 17 across all the blockchains in the world. We are the number 1 chain in unique active wallets with 12.4 million, with almost 2 million daily active address. And DAppRadar is a website that basically monitors the usage of all the decentralized apps, and 4 of the top 10 applications are built on top of NEAR. We also have almost 10 million daily transactions in the blockchain, with a total value locked of $316 million. And our transaction fees are very, very low. So on average, $0.06. We are also the number 3 in transactions per second, around 90, and number 3 in total transactions with 232 million. All right, so now let's talk about our implementation of our Lakehouse on top of Databricks and Google Cloud. So we have our blockchain running in our nodes, and then we have one special node called Indexer that basically extracts all the information from the blockchain and writes it into our NEAR data lake. So these are a bunch of JSON files. We have the blocks JSON file, which contains the information about the block. And because NEAR is a sharded blockchain, which means that we can scale infinitely, we have 1 JSON per shard as well. And then in our data lake house, we use autoloader to keep listening the bucket, and every new file that arrives, we ingest it near real time into our data lake. We also use DLT, which I'll show like some examples of code of how we did that, to transform this data, enrich it, and then make it more usable for our developers and our community. We also are using GCP BigQuery to democratize this data, so they don't need to do all this data transformation. They can just go to a free public BigQuery dataset and consume the data from there. So here are some examples. So this is our autoloader code that really shows how simple it is, our development experience. And we can use like just a few lines of Python to ingest these files, and just a few lines of SQL, which is very easy to maintain, to build our silver tables. All right, some real-world challenges that we had. When we choose Databricks and in Google Cloud, something that was really important to us was basically the scalability and reliability. We don't have an idea of when we will have like huge spikes in number of transactions. So we need something that was simple and easier to scale without like our team being worried on SRE activities. We want just to focus on the building the data pipelines, maintaining it, without worrying about like configuring machines and everything else. So the way that we do is just select the minimum workers that we want for our data pipeline, the maximum number of workers that Anirban mentioned that we now can go up to 15,000 nodes. And we select the instance types that fits in our workload. So in this chart, we can show that the first chart is by month, so number of transactions by month. And we experienced like 20x growth in the last months. And this is not linear. And we can see in the right chart that we have some very huge spikes. So the first one in November 30, we launched the possibility of inscriptions. And then that was very successful. And we basically saw like this very huge spike. And our cluster in JKE, it auto-scales seamlessly. We did not experience any outage because of that. And at the same time, once the load was gone, it scales down again without us being worried about like cost savings and anything. And also to talk about cost savings, we were able to ingest the same amount of data with the same budget that we had from the previous year in Databricks. So with the same money, we are able to keep ingesting this data. So that's pretty much our use case.
Thank you very much. Thanks for attending and have a great conference.
Thank you, everyone.